No? So fire away with questions you have.
For number, where was it? Supposed to sign X over X. 27, I think it was on page, either page, oh, yeah, wait, did you find it? I don't know. But on page 85 or 86, I don't remember which one, but on 27, it's like make sine X over X the extended function, but
okay.
I knew how to do it for the other ones, like just kind of factor and cancel, but I'm not quite sure how to do it for that one.
What number again? Sorry.
27.
Let's take a look at it. Yeah. So when asking to make an extended function, first of all, it's a very similar to example 8. So I notice I put some hints here. So if you look at the notes, that should help out some. In fact, let me pull up the notes here. Yeah, here we go. So you have all this stuff here. So you just want to follow that. So for 27, we see it's undefined for x equals 0, but if you graph it, you see there's a hole at 1. So you want to plug in that hole. That's what you rise.
Oh, so you just make it a piecewise function and say, okay.
Yep.
Oh, that's easy. All right.
25,
I thought they wanted like.
Yeah. Now 25, you could simplify like this, or you could do this.
Oh, no.
25, you can rise a piecewise function if you like.
Then I'll have no peace of mind, you know?
Oh, funny. Okay, like that. Write it as is, where x does not equal -3. And of course, you're going to plug in the hole because you know the simplified form is x minus 3. So you write that as well. So either way is totally accepted for 25. But for 27, you have no choice but to rise of piecewise. Okay, let's see if we have more questions in the chat. Number 5, I was confused as why is the jump discontinuity. I'll talk about that. And can I go over 33 and 35? Yes. Let me actually do 33 and 35 first. And then I'll go back to number 5. Oh, by the way, another thing I need to mention too. Yep, that's for stats. Put that down. I didn't initially assign 45 and 46. I don't know why, because I wanted to, because I put it as a hint here. So if you did 45, 46, great. If you didn't, that's fine too. I did update this morning because I do think that's important. So I am going to talk about, if I have some time, I'll talk about maybe 45 and then let you guys do 46 later. That's still with IVT. And I want to make sure you guys are getting that practice. So 45, 46 deal with IVT. 51 also does as well. And actually what I've done, I've actually worked out 45 and 46 and 51. I'm going to scan these this afternoon and put in the Schoology folder for week 4. Or actually, I'll put in test review materials. That might be better. And I'll label it like homework number 8, these solutions. And I'll give you guys an update as well once I've done that. Because that could help to see model answers for those kind of problems. And I'll do likewise for 47 through 50 as well. Okay, let's talk about 33, 35. Now 33, 35 says use theorem 7. That's kind of confusing unless you have the textbook, you can look it up. Theorem 7, this is why you want to look at the hints. Refers to the theorem mentioned near the bottom of page 4 of section 2.3 of the notes. So section 2.3 of the notes, page 4, right here. The bottom line is as long as you have individual functions that are continuous, when you combine and put them all together as a composite like we have here, the composite is also continuous. That is your job, is to deconstruct these functions here, give them individual names like f is this, g of this is whatever, and then write as a composite, because if you can prove that each of those individual parts are continuous, then the whole combination of it's continuous, right? So for example, let's say f of x equals x. I'll do 33. Let's say g of x is x plus 1. Are each of those continuous, yes or no? Yeah, they're all linear. Linear functions are continuous. Let's say h of x is root x. Is that continuous on its domain? Yes, it is too. Its domain is x is greater than or equal to 0. That's continuous on that domain, so that's also continuous. So I can write like this, and I'm all squared away, because each of those individual parts were continuous. So therefore, this is continuous, which represents this right here. So that's all good.
Do you have to specify that it's continuous on its domain in your answer?
Yeah, just a quick statement. Yeah. I probably, well, but I'll be honest with you, I'm probably not going to ask this on our test because it's too open-ended, and because I'm doing the Schoology platform, I'm probably not going to ask that. Like maybe I guess I could as a multiple choice, but it's just good to know. I think it's just more of just so you know. That's why we have this. For 35, you can let f of x equal 1 minus x. That's continuous. That's a linear function. You can let g of x equal cube root of x. Cube root of x has a domain of all real numbers. That's continuous because you can cube root negative numbers. H of x is cos x. Cos x, we know how that looks. Has no restrictions for x. You can put whatever you want for x. That's also continuous. So the combination of all that, I do as a double composite, h of g of f of x. All that is continuous. So that's 33, 35. I'm going to come back and do number 5 because someone asked about that. And I see there's more questions in the chat. So let me check that out. 19, why is 19 not removable? I'll talk about that. And number 7. So let me do 5 and 7 first, then I'll do 19. And 5 was, why is it a jump discontinuity? Okay, let's take a look at, oh, actually, hold on. Let me look at that one more time. Actually, no, 5 is not a jump discontinuity. It's 7 that's jump. 5's right here. That's for number 7. Yeah, so, but I could talk about that anyway. Oh, and number 7 of page 97, got it. I'll do that one. But yeah, number 5 is not jump. Number 5 is simply this. It starts at negative 1.5 on the x-axis and goes in this fashion. So all they're saying is that you're not continuous on x values that are not part of the domain, which, duh, of course. If you're not part of the domain, you're not continuous there because you have to exist to be continuous. Like, for example, number 5 is not continuous at x equals negative 2. Well, of course, because it's not part of the domain. f negative 2 does not exist. For number 7, it's jump because whatever your left-hand limit does not equal your right-hand limit, but they're each finite numbers. I believe the left-hand limit's -1 for number 7 and positive for number 7. And each are finite numbers. Then you would say a jump discontinuity. Whereas if they were going towards positive or negative infinity for left right-hand limits, you would say it's an infinite discontinuity like a number 1 or a number 9.
Mr. E.
Yep.
So for number 5, since it's asking to identify each type of discontinuity,
you can't identify it.
Word would you say?
Nothing. I have no idea.
Okay.
There's no label for it, unfortunately.
Okay,
so
it's just like all the points within the domain are continuous.
Yeah.
And that's it. Okay.
That's it. Yep. Yeah, it doesn't have a special label because just not part of the domain. Someone asked about 19. Why 19 is removable? So let's go through 19. Let me zoom in. Oh, sorry. The question was, why is 19 not removable? Got it. Well, it's actually a jump. So to be a removable discontinuity, here's what has to happen. The left-hand limit must equal the right-hand limit, but either f of c does not exist, or f of c does not equal the limit as x approaches c of f of x. That was what gives rise to remove discontinuity. So basically condition 2 has to pass, but condition 1 or 3, or both condition 1 or 3 fail. Sorry, both condition 1 and 3 fail. That's what has to be true for removal. Now in this case, the left-hand limit is 1, the right-hand limit is 2. The left-hand limit does not equal the right-hand limit. Of course, it's not continuous because it fails condition 2. Condition 2, if condition 2 fails, that won't be removable. That'll be a jump or an infinite discontinuity. That's why it's not removable. It's a jump instead for that reason. You need this to happen to be removable. That's not happening in number 19. So hopefully that clears that up. Keep moving here. Let me clear my screen. So someone asked about number 7. One sec here. Clear. It's gonna be a little annoying sometimes. There we go. I do want to work out 45, and I want to give you guys enough time to go into breakout rooms. But let's talk about number 7 here, because someone asked about that. Okay, for number 7, analytically, what we do when x is approaching positive or negative infinity for a rational function, you multiply top and bottom by 1 over x cubed. That's what you do analytically. And remember, we have this in our notes. If you go to notes 2.2, it's all right here. So your notes are your best friend. Make sure you know your notes well. And that's just that enough. In fact, you may even want to do an audit of your notes. I have all the fill out notes in Schoology. Make sure your notes are accurate and complete. And everything we've covered has been recorded and put in the Unit 1 playlist. So you have all the resources you need. So that's what you need to do. Multiply top and bottom by 1 over x cubed. So whatever the highest degree of the denominator is, we multiply it to every term in this rational expression. If you clean it up, so let's clean it up. You should have x4 over x3 plus x3 over x3 and then you have 12x3 over x3 plus 128 over x3. So you clean it up, that becomes 1. Those go away, it becomes 12. Of course, that becomes x. So you got x plus 1 over 12 plus 120 over x cubed. Now, don't get lazy. You do have to write the limit notation, so I got a little lazy there. When you take this limit, we should know that this approaches 0. We talked about this in the notes again. If you go to your 2.2 notes, yeah, 1 over x to the n, as long as your n's positive, that goes towards 0 when the limit as x approaches positive or negative infinity is happening, right? And then you have the 128, whoop-de-doo. Still, this whole 1 over x to the n thing is going towards 0. So you multiply 128 to 0, that's 0. So we don't worry about that. So really it's just x plus 1 over 12. Now, that is a linear function. That was like saying y equals 1/12 x plus 1/12. If I were to graph that, it would look like this, right? So now, what is happening to y as x goes forever to the right? Y is going up. What's happening to y when it's going further to the left? It's going down. Hence, the limit as x approaches positive infinity is this guy. The limit as x approaches negative infinity is that one. Because you're stuck with this after you simplified it. And of course, got rid of 120 over x cubed because that's essentially 0. So whenever it's top heavy, whenever the numerator has a higher degree than the denominator, there won't be a horizontal asymptote, meaning that the limit won't exist when x approaches positive negative infinity. And you could say that. If you said it does not exist, that's okay. Because you're not wrong. You're actually are still correct. But if you're being a little more explicit, if x is going towards positive infinity, that's your limit. If it's going towards negative infinity, it's that. Based upon the fact that we have a linear function with a positive slope. And if you just visualize the graph, that kind of makes sense. Y is going up forever to the right, down forever to the left. Okay, hopefully that's clear on that one. I know people asked about that too in other classes, so I think that's a fair question to ask. Okay, just I'm looking at time here. I do want to make sure you guys have time to do some work. Let me briefly talk about 45. Gosh, I wish I had scanned it already. Or I wish I had a document camera. Not sure if that. Oh, that's weird. What just happened there? Okay, it's like there's a little flicker. Okay. No, I'll just write it out. I was gonna work it out, but I mean, I was gonna try to show you the scan, but I didn't scan it yet. Let's work out 45 really quickly. So I did put a hint in homework number 8. And again, I forgot to assign. So if you didn't do it, don't worry, but you should practice over the weekend. So if you already submitted your homework, you don't need to resubmit if you don't want to. Again, I'm being very flexible with homework, so don't worry about that. But I did say here, you're going to be using IVT, and I'll tell you to use IVT in the test. So maybe it wasn't very clear to use IVT, but you have to. I didn't care about the statement in the second sentence of the question. I don't care what x equals. I just want you to prove the first statement. So you'll need to translate it, and then somehow that will become this. So I'll show you that translation in just a sec. And then, of course, follow the example laid out, follow the work laid out in example 11. Example 11 is right here. We're going to go through this right now. Connor, I see you have your hand raised. What's up, Connor?
Oh, yeah. Sorry, just quick clarifying question. Do you mind repeating what IDT is?
Yeah, totally. Actually, let me let me do that first. Yeah, we should know the big picture, right? So what is IVT? So let's break down the words. Intermediate means between, value, like a number, and a theorem, some sort of idea, right? What is this idea here? If you have a function and it's continuous, clearly this is continuous from what I see here, and you give it a contained interval or closed interval from A to B, any y value between f of A and f of B, so the y value at x equals A and the y value at x equals B, any y value in between those two y values can be taken off by this function here because it's continuous.
Sorry, it can be any y value between those 2 points.
Yeah, so let's make up numbers. Let's say this is x equals 2 and x equals 10. Let's say f of 2 was like, I don't know, So that's like 5. Let's say f of 10 is 8. Therefore, we do those little 3 dots as therefore. Therefore, f of x can equal any value between 5 and 8.
Got it. Okay.
So
And-
before we use,
Go
sorry,
ahead.
before we use this theorem, we have to like follow the 3 steps to ensure that the function is like fully continuous.
Not necessarily. Let me do one of the examples for you, because that's a lot of work to do. You can, but that's a lot. I'm going to show you. You can just do a quick workaround around that. But that might be a separate thing I could ask in a different question. But yes, fx can equal any value between 5 and 8 as long as f of x is continuous on the interval from 5 to 8. Sorry, on the interval from 2 to 10. Because remember, I was focused on an interval. Then that can happen. So that is IVT. Now, let's see in practice, like 45. 45 is kind of, give me 1 second here. I do a quick update. Okay. So you translate the statement. Is any real number exactly 1 less than its 4th power? Well, any real number, call it x. Exactly equals 1 less than its 4th power, x to the 4 minus 1. You have your mathematical statement now. I even put that in the hints as well. So is any real number exactly 1 less than its 4th power? There we go. Now what you need to do is put all terms on one side. And I do that in the notes as well. You have your equation, put all terms on one side. That way you get 0 on the other side. Then you're just going to, kind of a formality, let f of x equal your expression. If you do that, the question changes. The question now becomes, instead of the original statement, is any real number exactly 1 less than its 4th power? The question now becomes, does f of x equal 0? Because we deliberately took our translated equation, rewrote it, and called it f of x. And we want that to equal 0 to answer that question. So now that's our goal. And we use IVT to realize that goal. So how do I use IVT to realize that goal? Well, I first need a couple of x values. I need to make an interval. And that's usually sometimes the hardest part. You know, sometimes people have a hard time making an interval, but it's not that bad if you just don't let it get the best of you. For example, what if x equals 0? What's y going to equal here? -1. That's an easy one to work with. Again, in the notes, I do the same thing. You know, I make the function negative, make it positive. Try a lot of different x values that might give us that. So I tried x equals 0, I got -1. What if I do x equals 2? I get 16 minus 2 minus 1 is 13. So it's not that hard. So now I found an interval. My interval is going to be 0 and 2. So on the x-axis, here's x equals 0, x equals 2. F of 0, of course, is -1. So I have a dot right here. F of 2, of course, is 13. I have a dot right here. And f of x is continuous. So to answer your question, Ella, you don't need to go through that whole process. Fx is continuous because it's a polynomial. All polynomials are continuous. So you could just say that. So now we're ready to put it all together. So again, translate the equation, set it equals 0, call it f of x. Question now becomes, does fx equal 0? Well, let's plug in a couple of x values, one that's positive, one that gives a positive y value, one that gives a negative y value. And as long as your function is continuous, we're now ready to make the final statement. The final statement will look like this. Because f of x is continuous on the interval from 0 to 2, and that f of 0 had equaled -1, and f of 2 had to equal 13, then f of x must equal 0 due to IVT, which states that f of x can equal any y value between f of a and f of b on the interval, or sorry, as long as, by the way, I have this written more neatly on a piece of paper, and I will share that with you guys in school, don't worry. As long as f of x is continuous on a to b. That's a lot of writing, but let me restate that one more time. Because our function is continuous on that interval, and that f of 0 equaled -1 and f of 2 equaled, oh my god, equals 13, then f of x must equal some number between -1 and 13, hence 0, due to IVT. Because IVT states that you could take on any y value between f of a and f of b as long as your function is continuous on the interval from a to b. That's the intermediate value theorem. On the board problems, number 2 is another example you guys can do to try the intermediate value theorem. And actually the solutions for the board problems are in school, just so you can check to see if you're doing it right. So that's what I'm gonna have you guys do. I'm gonna stop sharing.